The cosmos continues to reveal its myriad mysteries and opportunities, with recent developments from NASA highlighting both humanity's ingenuity in exploring the universe and the enduring enigmas that lie within it. From leveraging lunar light for enhanced scientific precision to grappling with an unexpected signal from a decades-old dead satellite and even encouraging public engagement with our own galaxy, the agency remains at the forefront of pushing the boundaries of our understanding. In a forward-looking technological leap, NASA announced on June 20, 2025 plans to harness moonlight to significantly enhance measurements taken from space. This innovative approach aims to utilize the moon's consistent reflected sunlight as a stable calibration source for instruments aboard Earth-observing satellites. By precisely measuring the moonlight, scientists can ensure the accuracy and reliability of data collected on Earth's atmosphere, oceans, and land surfaces. This method promises to refine climate models, improve environmental monitoring, and provide unparalleled consistency for long-term observational studies, marking a subtle yet powerful advancement in remote sensing capabilities that could yield more precise insights into our changing planet. However, the tranquility of scientific advancement was juxtaposed with a perplexing event that same week. On June 20 and 21, 2025, reports emerged from IFL Science and Cron detailing a mysterious powerful radio pulse traced back to a NASA satellite that has been dormant since 1967. The sudden emission from a spacecraft that had long been considered space junk has baffled experts. This particular satellite, having been silent for nearly 6 decades, unexpectedly burst back into communication with a massive radio signal. The cause of this spontaneous reactivation remains unknown, sparking intense speculation among the scientific community. Theories range from residual power sources being activated by unforeseen environmental factors like solar flares or micrometeoroid impacts, to highly improbable but intriguing possibilities of unforeseen orbital dynamics or even novel physics. The incident underscores the unpredictable nature of objects in space, raising questions about the longevity of defunct technology and the potential for long-term space debris to pose unexpected challenges or conversely offer unique opportunities for study. Investigations are undoubtedly underway to decipher the origin of this phantom signal and its implications for space operations and orbital mechanics. Amidst these technological feats and cosmic mysteries, NASA also extended an invitation to the public to reconnect with the awe-inspiring beauty of the universe closer to home. Forbes reported on June 21, 2025 that NASA is urging the public to seek out dark sky locations to witness the spectacular appearance of the Milky Way. This call to action emphasizes the growing problem of light pollution, which increasingly obscures our view of the night sky, particularly for those residing in urban areas. By encouraging people to venture to places with minimal artificial light, the agency aims to foster a deeper appreciation for astronomy and our place within the vast cosmic tapestry. This initiative not only serves as a reminder of the natural wonders above but also implicitly advocates for conservation efforts to protect dark sky environments, which are crucial for astronomical research and for preserving humanity's connection to the stars. These disparate but equally compelling narratives collectively paint a vibrant picture of contemporary space exploration. They illustrate NASA's multifaceted role, pioneering advanced technologies for scientific discovery, confronting unexpected challenges posed by the space environment, and nurturing public wonder and engagement with the cosmos. As we look ahead, the pursuit of precision through lunar calibration, the ongoing unraveling of the enigmatic radio pulse, and the continued effort to bring the wonders of the night sky to wider audiences promise to keep humanity's gaze firmly fixed on the infinite possibilities that space holds. The boundless frontier of space continues to captivate humanity, yet recent developments underscore both the routine complexities and unexpected challenges inherent in our orbital endeavors, alongside a burgeoning shift in the global landscape of space exploration. From the diligent operations aboard the International Space Station (ISS) to the unforeseen technical glitches impacting private missions and the emergence of new players on the cosmic stage, the past week has painted a vivid picture of a dynamic and increasingly intricate space ecosystem. As of Friday, June 20, 2025. The crew of Expedition 73 aboard the International Space Station concluded a week that blended essential maintenance with personal well-being, as reported by NASA. The astronauts engaged in a mix of light science experiments, periods of relaxation, and a critical emergency drill. Such drills are a testament to the rigorous safety protocols and preparedness vital for sustained human presence in the unforgiving environment of low Earth orbit, ensuring the crew is ready for any contingency. This routine, however, was soon overshadowed by a more pressing concern. Just hours after NASA's update and into Saturday, June 21, reports emerged from multiple sources including Space.com and MSN detailing a leak detected on the International Space Station. This incident, though details regarding its precise location or severity were not immediately widely disseminated, had immediate repercussions. It prompted a delay in the highly anticipated SpaceX launch of the Axiom-4 astronaut mission. Such delays are not uncommon in space operations where safety is paramount. But a leak on the venerable orbital outpost highlights the constant vigilance required to maintain the integrity of a structure that has been continuously inhabited for over 2 decades. The cause of the leak, whether a micrometeoroid strike, material fatigue, or another factor, will undoubtedly be the subject of thorough investigation, underscoring the inherent risks and the delicate balance of engineering and human resilience that defines life in space. The ripple effect on commercial space missions like Axiom's demonstrates the interconnectedness of public and private ventures in current space activities, where the health of the foundational orbital infrastructure directly impacts the pace of new initiatives. Adding another layer to this evolving narrative, the United Nations News on Saturday, June 21, 2025 published an analysis titled "From the Global South to the Stars, a New Space Race." This piece illuminates a significant geopolitical shift in space exploration, moving beyond the traditional bipolar or tripolar competition. Nations from the global south are increasingly asserting their presence and capabilities in space, driven by aspirations for technological independence, economic development, and addressing local challenges through satellite applications. This new space race is characterized less by a zero-sum competition and more by diversified participation, fostering new collaborations and potentially more equitable access to the benefits of space. However, it also introduces new complexities regarding orbital debris management, spectrum allocation, and the establishment of international norms, issues that become even more salient as more actors gain access to space. In essence, the recent events paint a comprehensive picture of contemporary space exploration, a field where established entities like NASA continue their vital research and operational routines, while unexpected technical challenges like the ISS leak demand immediate attention and adaptive responses. Concurrently, the landscape is broadening, with new national players, particularly from the global south, reshaping the geopolitical dynamics of the cosmos. This confluence of factors emphasizes that humanity's future in space will be defined not only by technological prowess and scientific discovery, but also by a commitment to safety, international cooperation, and the responsible stewardship of an increasingly accessible yet still unforgiving frontier. As the Axiom-4 mission awaits its rescheduled launch and the ISS leak is addressed, the coming months will reveal how these intertwined threads continue to weave the fabric of our journey to the stars, the intricate ballet of human spaceflight, a testament to technological prowess and human ambition, continues to unfold with its characteristic blend of challenges, triumphs, and the persistent need for factual clarity. Recent developments within the space sector underscore this dynamic landscape, from critical operational delays stemming from orbital infrastructure issues to celebratory recognitions of pioneering figures. All while the digital realm grapples with the spread of misinformation regarding life beyond Earth. A significant disruption emerged on Saturday, June 21, 2025, when a leak detected on the International Space Station ISS directly impacted the highly anticipated SpaceX launch of the Axiom-4 astronaut mission. Originally slated to carry its crew to the orbital outpost, the mission has been put on hold as Mission Control prioritizes the safety of the 7 astronauts currently aboard the ISS and focuses efforts on identifying and rectifying the source of the leak. This incident, initially reported on Friday, June 20 by sources like space.com and subsequently confirmed by MSN, highlights the inherent fragility and complexity of maintaining a habitable environment in the unforgiving vacuum of space. Such delays, while frustrating for mission planners and the public alike, are standard procedure when safety protocols dictate a thorough assessment and resolution of any potential risks, ensuring the integrity of the station and the well-being of its inhabitants. The meticulous nature of space operations means even a seemingly minor technical issue can cascade into significant schedule adjustments, underscoring the delicate balance between ambitious exploration and rigorous safety standards. Amidst these operational adjustments, the human element of space exploration received a well-deserved spotlight on Friday, June 20, 2025. The U.S. Astronaut Hall of Fame inducted a former medical center doctor, a connection proudly highlighted by the Austin Daily Herald. This recognition serves as a potent reminder of the diverse expertise and dedication required to push the boundaries of human presence in space, extending far beyond the pilots and engineers to include vital medical and scientific contributions. Such accolades not only honor individual achievements but also inspire future generations to pursue careers in the multifaceted field of space science and exploration. However, the digital age also brings its own challenges to the narrative of space exploration, particularly in the form of pervasive misinformation. On Friday, June 20, 2025, AFP Fact Check published an article debunking a viral video falsely claiming to show an astronaut exposing fake life in space. This incident underscores the critical role of professional journalism and fact-checking organizations in combating conspiracy theories and ensuring that public understanding of space endeavors remains grounded in verifiable scientific reality. In an era where sensationalism often trumps accuracy, the diligent effort to correct false narratives is crucial for maintaining public trust in scientific institutions and the legitimate advancements being made in space. Collectively, these recent events paint a comprehensive picture of the current state of space exploration, a field characterized by relentless innovation, the constant management of inherent risks, the celebration of human ingenuity, and the ongoing battle against disinformation. The temporary halt of the Axiom-4 mission due to the ISS leak serves as a powerful reminder of the unforgiving nature of space and the paramount importance of safety. The induction into the Astronaut Hall of Fame reaffirms the profound human stories behind every launch and discovery. And the swift debunking of online falsehoods highlights the responsibility of the media to uphold truth in an increasingly complex information landscape. As repairs on the ISS progress and the Axiom-4 mission awaits its rescheduled launch, the world watches, reminded that the journey to the stars is as much about resilience and integrity as it is about rockets and orbital mechanics. The boundless ambition of space exploration and scientific inquiry continues to push the frontiers of human knowledge. Yet even the most visionary endeavors operate within earthly constraints. Recent developments paint a complex picture of innovation and challenge, from leveraging celestial light for enhanced measurements to the stark realities of budgetary pressures impacting a pivotal research center, all while ground-level atmospheric studies unfold across American skies. In a remarkable stride for space science, NASA announced on June 20, 2025, a pioneering technological advancement poised to revolutionize how measurements are taken from orbit. The agency is developing sophisticated tech designed to harness the consistent diffuse light of the moon to significantly enhance the precision and accuracy of data gathered by instruments in space. This innovative approach promises to provide an invaluable calibration source, allowing for more reliable long-term climate monitoring, Earth observation, and deeper insights into planetary atmospheres. Such enhancements are critical for detecting subtle environmental changes and validating complex scientific models, underscoring NASA's continuous pursuit of cutting-edge methods to extract more granular information from our cosmic vantage points. Concurrently, residents across parts of Virginia, specifically Hopewell, Petersburg, and Colonial Heights, have been observing a series of low-flying airplanes conducting specialized research missions. These aerial operations, reported on June 20 and 21, 2025, are part of ongoing scientific efforts to collect atmospheric and environmental data. While the specific agencies involved were not detailed, such flights are typically undertaken by government or academic institutions to monitor air quality, map terrain, or study weather patterns, providing crucial localized data that complements broader satellite observations. The presence of these research aircraft serves as a tangible reminder that scientific exploration isn't confined to distant orbits but is also actively unfolding in our immediate skies, contributing to a comprehensive understanding of our planet. However, the landscape of scientific pursuit is not without its significant hurdles. A stark contrast to these advancements emerged with news on June 21, 2025, detailing a proposed 40% workforce reduction at NASA's Langley Research Center, a critical hub of aerospace research and development in Hampton, Virginia. This substantial cut is reportedly part of a budget plan put forth by the Trump administration, signaling a potential seismic shift in federal science funding. A reduction of this magnitude could have profound repercussions, leading to a significant loss of institutional knowledge, a slowdown in ongoing research projects, and a diminished capacity for future innovation at one of NASA's oldest and most prolific centers. The prospect of such widespread layoffs highlights the precarious balance between scientific ambition and political fiscal priorities, raising questions about the long-term health and competitiveness of American scientific leadership. These disparate but interconnected narratives collectively paint a vivid picture of the current state of technological and scientific endeavor. On one hand, we see the relentless push for innovative solutions like leveraging moonlight for unprecedented measurement accuracy and the continued commitment to vital environmental data collection through airborne research. On the other, the proposed deep cuts at a foundational institution like NASA Langley underscore the persistent challenges of securing consistent, robust funding for scientific research. This paradox of groundbreaking innovation occurring simultaneously with severe budgetary constraints forces a re-evaluation of national priorities. The ability to push the boundaries of knowledge, whether in the vastness of space or the immediate atmosphere, is inextricably linked to the sustained investment in the human capital and infrastructure that make such breakthroughs possible. As these events unfold, the scientific community and policymakers alike will be closely watching to see how these forces shape the trajectory of future discoveries and the nation's role in the global scientific landscape. Mars, the enigmatic red planet, continues to yield groundbreaking secrets, with recent announcements from NASA painting an increasingly dynamic and complex picture of its geological past and present. From the clarification of mysterious radioactive traces to the stunning discovery of a hidden volcano, these revelations are not only deepening our understanding of Earth's planetary neighbor but also reshaping the very textbooks of Martian geology. Among the most significant recent findings is the confirmation by NASA of a previously overlooked volcano reportedly discovered in plain sight near one of its active Mars rovers. This revelation, widely reported across various science outlets, suggests that our maps and models of the Martian surface may require significant updates. The implications of finding such a feature, which had eluded detection or proper identification for so long, are profound. It indicates that Mars's internal heat engine might have been more active more recently than previously thought, challenging existing theories about the planet's thermal evolution and its potential for past habitability. The presence of volcanic activity is a critical factor in understanding the outgassing of volatiles, the formation of atmospheres, and the cycling of elements essential for life. This discovery underscores the power of persistent on-the-ground exploration by rovers whose detailed sensor data and close-up imaging can unveil features that even orbital reconnaissance might miss or misinterpret. Adding to the evolving narrative of Mars, NASA has also moved to clarify the origin of certain radioactive traces detected on the Martian surface, addressing what had previously been considered unexplained phenomena. Crucially, the agency has definitively ruled out the speculative notion that these traces were the result of nuclear explosions. This clarification is vital for dispelling misinformation and reinforcing the scientific understanding that these radioactive signatures are in fact attributable to natural geological processes. Such detailed analysis likely stemming from instruments on board rovers like Curiosity, which regularly monitors its environment, demonstrates the meticulous approach scientists take to interpret data, differentiating between naturally occurring phenomena and more dramatic, less likely explanations. This rigorous scientific process prevents misinterpretations from gaining traction and ensures that our understanding of Mars is built on solid, verifiable evidence. In the midst of these significant scientific breakthroughs, the ongoing daily operations of missions like the Curiosity rover continue to provide a steady stream of data. Recent entries in the Curiosity blog covering Sols 4577 to 4579 remind us of the rover's persistent vigil, urging us to watch the skies. While seemingly a simple directive, this highlights the broader scope of Curiosity's mission, which extends beyond geology to include atmospheric studies, climate monitoring, and observations of celestial events from the Martian surface. These atmospheric and environmental data points are critical context for understanding the geological processes at play, influencing everything from weathering patterns to the distribution of minerals, and ultimately informing scientists about the conditions that might have allowed for ancient life on Mars. Collectively, these recent announcements from NASA underscore the iterative nature of scientific discovery. As our sophisticated robotic explorers continue to traverse the Martian landscape, they not only uncover new features but also provide the necessary data to re-evaluate existing observations and refine our understanding of the planet's complex history. The discovery of a hidden volcano and the clarification of radioactive traces illustrate how new data can both introduce exciting new mysteries and resolve old ones, continuously reshaping our planetary narratives. As humanity looks towards future crewed missions to Mars, this evolving geological and environmental picture is indispensable, guiding where we explore next and what questions we seek to answer about the red planet's past, present, and future potential. The unforgiving vacuum of space continues to present formidable challenges, particularly for the delicate dance of a lunar landing. In a stark reminder of these complexities, NASA's Lunar Reconnaissance Orbiter (LRO) has recently confirmed the impact site of a SpaceX HAKUTO-R Mission 2 moonlander, offering a poignant visual of the ambitious private mission's unfortunate conclusion. This latest imagery, released by NASA and corroborated by reports from Space.com and ABC News this past week, provides crucial data for understanding the dynamics of lunar descent failures and underscores the inherent difficulties in reaching our celestial neighbor. The HAKUTO-R Mission 2, a significant endeavor by the Japanese private lunar exploration company ispace, aimed to achieve what only a handful of nations have accomplished: a soft landing on the Moon. Building on lessons from its predecessor Mission 1, which famously failed its landing attempt in April 2023, Mission 2 represented a renewed push for commercial lunar access. However, the latest observations from LRO, captured by its high-resolution cameras, reveal a new crater and associated debris field on the lunar surface, characteristic of a high-velocity impact rather than a controlled touchdown. This visual evidence serves as the definitive grave of the lander, as Space.com aptly described it, confirming that HAKUTO-R Mission 2 succumbed to the perilous final moments of its journey. The discovery of the impact site by LRO is not merely an exercise in post-mortem analysis, it is a vital contribution to the collective knowledge base of lunar exploration. NASA's orbiter, a veteran surveyor of the Moon since 2009, routinely captures detailed imagery of the lunar surface. By comparing before and after photographs of the targeted landing zone, LRO's scientific team was able to identify the distinct changes wrought by the impact. This capability is invaluable, allowing engineers and scientists to reconstruct the events leading to the failure, assess the likely causes, whether a miscalculation in thrust, an issue with navigation, or an unexpected topographical challenge, and feed these insights back into the design and operational parameters of future missions. For ispace, while undoubtedly a setback, this confirmed data is critical for refining their technology and procedures for subsequent attempts, demonstrating the iterative and often unforgiving nature of spaceflight development. The repeated challenges faced by private entities like ispace highlight the sheer technical complexity of lunar landings, even as the global space industry increasingly looks towards commercial partnerships for lunar access. While government agencies like NASA have decades of experience, the new wave of private companies often operates with leaner budgets and different development timelines, pushing the boundaries of what is possible. Each failure, though costly, provides an invaluable albeit harsh lesson. It reinforces the need for robust testing, redundant systems, and meticulous planning, serving as a cautionary tale for the burgeoning lunar economy. Yet, it also speaks to the incredible ambition and resilience of these companies, who are undeterred by adversity in their pursuit of establishing a sustainable presence on the moon. Looking ahead, the confirmation of HAKUTO-R Mission 2's impact site will undoubtedly contribute to the broader understanding of lunar environments and the precise requirements for successful landings. As NASA's Artemis program and various international and private initiatives gear up for more frequent lunar missions, including human returns to the moon, the data gleaned from such incidents becomes ever more precious. The detailed imagery and analysis from LRO will help inform landing site selections, improve hazard avoidance systems, and refine guidance algorithms for future landers, both robotic and crewed. The moon remains a challenging destination, but each step, even a misstep, brings humanity closer to mastering its complexities, paving the way for a more permanent presence beyond Earth.